In this lesson, I'll show you 3 more examples on how to solve first-order differential equations. The first question reads, find the general solution of the differential equation. The first thing that we have to do is switch this y prime into dy over dx. dy over dx, and then we want to separate the y terms from the x terms. Notice that the x terms are in the numerator position, whereas the y terms are in the denominator position of this fraction. So if I multiply both sides right now by y to the power of 7 plus y, I end up with the following. Y to the power of 7 plus y on the left side, and x to the power of 3 plus sine x on the right side. Next, if I multiply both sides by dx, this dx and this dx will cancel out, and we'll have 1 on the right side. So now we have y to the power of 7 dy plus y dy. Notice that I multiplied this dy into these two terms. And over here we'll have x to the power of 3 dx plus sine x dx. Our next step is to integrate. So I'll take the integral of the left side and the integral of the right side. Taking the integral of the left side, I'll integrate this first term. I end up with y to the power of 8 over 8. We've just taken care of that term. Now the integral of y dy is y to the power of 2 over 2. And now on the right side we have x to the power of 4 over 4 plus the integral of sine x is actually negative cosine x. Just like with all integration, we always include a constant, so I'll include a constant over here. This right here represents the general solution of this equation. Moving on to question 2, we're asked to solve e to the power of x to the power of 2 times y prime plus x is equal to 0. Once again, I want to switch this into dy over dx. So that will be that y prime. And beside it, we have y times e to the power of x to the power of 2 plus x is equal to 0. What I'll do to separate the x and y terms is I'll take this x term to the right side. This gives me negative x on the right side, and on the left side we have dy over dx y e to the power of x to the power of 2. I'll divide both sides by e to the power of x to the power of 2. This cancels out on the left side, and on the right side we have it underneath. So now we have y times dy over dx is equal to negative x over e to the power of x to the power of 2. Multiplying both sides by dx cancels it out on the left side, and this gives us the integral of y with respect to y on the left side and the integral of negative x over e to the power of x to the power of 2 dx on the right side. Now integrating the left side is easy. In fact, it's y squared over 2. But integrating the right side requires a little bit of math finesse. Take a look. We have e to the power of x to the power of 2 at the bottom. I can write it out like this. The integral of negative x, this negative can be pulled out, and we have e to the power of negative x to the power of 2. That way they're all in one line. Next, I'll substitute a letter in for negative x squared. Let's choose u. And I'll take the derivative of both sides with respect to x. du is equal to negative 2x dx. Solve for dx, so I substitute it into there. du over negative 2x is equal to dx. I'll place this now into here, where I have negative times the integral of x e to the power of u du over negative 2x. This negative cancels out with this negative, this x cancels out with this x, and we're left with 1 over 2 times the integral of e to the power of u du. The integral of e to the power of u is e to the power of u, and that gives us the answer on the right side. We have 1 over 2 e to the power of u, which I'll replace back with negative x squared plus c. This represents the general solution for question 2. Finally, in question 3, they want us to find the general solution of dy over dx is equal to negative x over y. And I've also written down here, do not solve for y unless asked to. I'm going to explain to you why I wrote that after I find the general solution. First, I'll multiply both sides by y, and then multiply both sides by dx. If I do that, I end up with y times dy is equal to negative x dx. Taking the integral of the left side gives me y to the power of 2 over 2. And the integral of the right side gives me negative x squared over 2 plus c. Now, normally when you encounter questions like these, differential equation questions, you will be expected to solve for y. So if I solved for y here, I would multiply both sides by 2. The 2's would cancel out, and I would end up with a 2 over here, where I would end up with y squared is equal to negative x squared plus 2c. Square rooting both sides would give me y is equal to a positive version, where I have the square root of negative x squared plus 2c, and a negative version. The problem is, by doing this, you don't really have a good understanding or a visual of what this equation is doing, or what this equation is telling us. For example, had I moved this over here, I would end up with y to the power of 2 plus x squared is equal to 2c. This right here represents the equation of a circle. So this gives me a better understanding of what this equation is telling me versus the one that we see in orange. In fact, the circle here would have a radius of the square root of 2c. And there you have it. 3 examples on how to solve first-order differential equations.